Hello, this is Tricky Calculations with Dr. John. I'm Dr. John, and today's tricky calculation will be on ideal gas equation. So here is our question. A sample of pure magnesium nitrate was decomposed by heating as shown in the equation. We are given the mass of the magnesium nitrate and we are asked to calculate the total volume in cm³ of gas produced at 60 degrees C and 100 kilopascals. We're asked to give our answer to the appropriate number of significant figures and we're given the gas constant. Why is this question tricky? First, well, we've been given volume, pressure, and temperature, which tells us that we need to use the ideal gas equation. But notice that magnesium nitrate is not a gas. This means that we cannot use the number of moles of magnesium nitrate as N in the ideal gas equation. Number two, there are multiple unit conversions that we must complete. For example, we must first calculate the number of moles of magnesium nitrate from mass. We do that by taking the mass of magnesium nitrate that was given and dividing that by the formula mass, which is 148.3. Now, this gives us a number of moles for magnesium nitrate, which is 2.522 times 10 to the power negative 4 moles. Next, we convert the moles of magnesium nitrate to the moles of gas. If you look at the equation, you see that for every 2 moles of magnesium nitrate that decomposes, we get 4 moles of nitrogen 4 oxide and 1 mole of gas. This means that we must divide the number of moles of magnesium nitrate which we obtained by 2 and then multiply by 5. Again, to be clear, the 5 comes from 4 moles of nitrogen 4 oxide and 1 mole of oxygen. When we do that, we get the total number of moles of gas as 6.305 times 10 to the power negative 4 moles. Next, we must convert 2 kelvins from degrees Celsius and we must convert to pascals from kilopascals. To do that, we add 273 to the value of the temperature, and that gives us 333 Kelvin. And then for pascals, we multiply the value in kilopascals by 1000, and that gives us 100,000 pascals. Now, we can make V subject of the formula and then calculate. To do this, we say that V is equal to nRT over P. We get this from PV equals nRT, and we divide both sides by P. Then we substitute as shown there, and our answer is 1.745 times 10 to the power negative 5 meters cubed. Now, it is important that we remember that our answer is in meters cubed. The SI unit for volume is meters cubed. This is important because we have to convert this volume to cm³. Now, there's a very simple way that I teach students to do this. Instead of thinking about how do I convert from meters cubed to cm³, first we convert from cm to meters. So from centimeters to meters. We have 100 cm gives us 1 meter. Then we cube all parts of that equation. So we say 100 cube cm cubed equals 1 cube meters cubed. Now, 1 cube is 1. So this means that 10 to the power 6 cm³ is equal to 1 meter cube. If you notice, the cm³ side is bigger than the meter cubed side. So if we have a value in meters cubed, we will multiply so as to generate the cm³ side. And if we have a value in cm³, then we will divide so as to generate the meter cube side. So to convert to cm³, we say our value in meters cubed multiplied by 10 to the power 6 cm³ per meters cube, and that gives us 17.45 cm³. Now, very importantly, our question is telling us that we need to give our answer to the appropriate number of significant figures. This is often a banana peel for many students because they don't know what is the appropriate number of significant figures. To determine this, we look at the question. We're given the mass as 3.74 times 10 to the power negative 2. That is 3 significant figures. We're given our temperature as 60.0 degrees Celsius. Now, the 0 after a decimal point is significant. Therefore, that is also 3 significant figures. 100 kilopascals is actually 1 significant figure. and R is given as 8.31 joules per kelvins per mole, which is 3 significant figures. So we want to give our answer to 3 significant figures. Now 17.45 to 3 significant figures will be 17.5, because we will round up the 4th significant figure, which is 5. We'll round that up and our answer will be 17.5 cm cube. Okay, let's take a look at how this question will be marked. First, converting the mass of magnesium nitrate to moles will be M1, so the first mark. Then obtaining the correct number of moles of gas will be the second mark. M3 would be the unit conversions that are necessary, so converting the temperature, converting the pressure will be M3. M4 would be to obtain the volume by substituting into the equation. M5 is going to be converting that volume in meters cubed to the appropriate number of significant figures in cm cube. Okay, I hope that this has been a wonderful experience for you. Please go back and watch it over and see what mistakes you would have made and how you can solve this question without any problems. I want you to stay connected for more, because there will be more episodes of this tricky calculation series. See you in the next one. Cheers.